The study of geometry of motion, or kinematics, requires us to understand concepts such as distance, displacement, speed, velocity, and acceleration. In this video, we will define and relate each of these quantities for us to be able to use them in the study of motion of particles. We will start by relating distance and linear displacement. Distance is a scalar quantity which is defined as the total length of the path covered by a particle, while linear displacement is a vector quantity which describes how far out of place did the particle went from its original to its final position, or at a certain position at the time being considered. For example, a particle that moves from A to B following the arc path has a distance of magnitude equal to the length of the arc AB. Moreover, its linear displacement is equal to the arrow AB, or simply delta S. Theta is the angle between the change in the value of x and the change in the value of s, or the displacement in this case. If, for example, the particle will move along from A, traversing the arc up to point B, and moving back again to A, the distance traveled by that particle is twice the length of arc AB. Its linear displacement now will just be equal to 0, since the starting point is also where the final position is. If the path of the particle when it moves from A to B is following the straight line AB, the distance and displacement will both have a magnitude equal to the length of line AB. Linear displacement is a vector quantity. That is why the magnitude and direction of delta S, or linear displacement, may be expressed by the equations delta S is equal to the square root of delta x, the quantity squared, plus delta y, the quantity squared. This came from the Pythagorean theorem. And using the tangent function, we can express the direction of the displacement by using tangent theta is equal to delta y divided by delta x, opposite over adjacent. The vector quantity linear velocity at any moment that the particle is moving along the path AB is the time rate of its linear displacement, or simply the change in position with respect to time. Delta S is the change in position, while delta t is the change in time. The instantaneous velocity, considering a very short time interval, is given by the ratio delta S over delta t. In mathematical form, velocity is equal to the limit of delta S over delta t as delta t approaches 0. In other words, velocity is equal to the derivative of the position with respect to time. The magnitude of the particle's velocity is called the speed. In other words, the instantaneous velocity, or the linear velocity of a particle, considers both the magnitude and direction of the change in position of a particle while it is in motion, while speed is only considering the magnitude of the change in position of a particle's motion. Linear acceleration at any moment that the particle is moving along the path AB is the time rate of its linear velocity, or simply the change in velocity delta v with respect to time, or delta t. The instantaneous acceleration, considering a very short time interval, is given by the ratio delta v over delta t. In mathematical form, just like in the linear velocity, acceleration is equal to the limit of delta v over delta t as delta t approaches 0, or simply acceleration is equal to the change in velocity with respect to time. In rectilinear motion, delta v, or the change in velocity, may be caused by a change in magnitude only, that is varying speed and not changing direction. If in case there is constant speed and you are only changing the direction of the motion of the particle, then there will be no acceleration. You are considering constant speed. In curvilinear motion, however, delta v may be caused by a change in direction only, that is constant speed and varying direction, or a change in both magnitude and direction, that is, of varying speed and direction, while traversing the curved path. As a summary, distance is a scalar quantity which is equal to the total length covered by a particle in motion. Linear displacement, a vector quantity, is how far out of place did the particle went. The scalar quantity speed is the total distance covered over a period of time, while velocity is equal to the speed but considering direction. That is why it is a vector quantity. And lastly, linear acceleration measures the time rate of change of velocity, and that is why it is also a vector quantity. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.